Good evening. Welcome back to our class. We were to start on working on examples on hypothesis testing. So we are going to start with the hypothesis test about one population mean. Hypothesis test about one population mean. Hypothesis test about one population mean. As you can recall, about hypothesis testing is using sample data to verify or ascertain a known or assumed population characteristics. So you do not just use the given population characteristic as it is. You are using the sample data to ascertain whether it's true or not. So if the sample data ascertains that the given parameter is true, you are going to accept the null hypothesis. If the sample data verifies that it's false, you accept the alternative hypothesis. So when it comes to hypothesis test about one population mean, we are going to use either the Z-test or the T-test. So in Z-test, used when the sample size is above 30. Sample size is above 30 and above. T-test is used when the sample size is less than 30. T-test is used when the sample size is less than 30. So let's look at May 2017 question 3A. May 2017 question 3 part A. It says Mwangaza Limited bulbs produced by the company yielded the following results on the lifetime of the bulbs. So we have the lifetime in hours of the 10 bulbs given. Then the hypothetical population mean is given us 4,000 hours. Required test at 5% significance level, whether there's a significant difference between the sample mean and the population mean. So that's what is required. So what we've seen there already, the sample size is 10. So when the sample size is 10, and have it that we are going to use a t-test. Then we've been provided with the population mean of 4,000 hours. So the population mean that we've been provided with is 4,000 hours. So the sample data that we've collected now, we want to verify, ascertain whether we are going to accept these 4,000 hours as the hypothetical mean of the bulbs that is produced by the Mwangaza Limited. Just to remind you on the steps of hypothesis testing, we said that in step 1, you are to state the null and alternative hypothesis. State the null and alternative hypothesis. Step number 2, you are to determine the critical t-value. Determine the critical t-value or z-value at chosen level of significance. Because determining the critical t-value will help you to ascertain the rejection and acceptance regions. Then step number 3, what do? You determine test statistic. You determine the test statistic. Step number 4, using the critical values, you now determine the acceptance. You have to come up with the acceptance and rejection regions. You come up with the acceptance and rejection region. Then step number 5, it's now the decision. So if the test statistic falls in the acceptance region, you accept or fail to reject null hypothesis, and if the test statistic falls in the rejection region, you reject null hypothesis and accept alternative hypothesis. So let's start here. And then even before we go to the question, recall the type of test can either be a one-tailed or a two-tailed. So one-tailed will happen when the direction of alternative hypothesis has been specified. So direction of alternative hypothesis, if it is less than or if it is greater than a given value, or it can also be stated as less than or equal to or greater than or equal to. Two-tailed test is used when the direction of null hypothesis has not been specified. So if the direction has not been specified, we are going to use a two-tailed test. So let's go to the question, May 2017, question number 3, part A. May 2017, question 3, part A. So let's start with step 1, the null and alternative hypothesis. Null and alternative hypothesis. So we've been told that the hypothetical mean of the lifetime of electric bulbs given us 4,000 hours. So we are going to say that HO, this is the null hypothesis. We are told that the hypothetical mean is what? 4,000 hours. HA, alternative hypothesis, the direction has not been specified. So if the direction has not been specified, here automatically we are going to use the two-tailed test. So you're going to say that the hypothetical mean is not 4,000 hours. So if it's not 4,000 hours, it can be less or greater than the 4,000 hours. That is step 1. So step 2, here the sample size is 10. So we are going to determine the critical t-value. So it's the critical t-value at alpha is equal to, alpha is the level of significance. So we've been given a level of significance as 5%. So alpha is 0.05. Remember, you can either be provided with the confidence level or the level of significance, but have it this way, that 1 minus the confidence level should give you the level of significance. So let's determine the critical value from t-table. So t-table, we're also going to determine degrees of freedom. Degrees of freedom is n minus 1. So degrees of freedom here will be 10 minus 1. So we are going to have 9 degrees of freedom. So let's determine that. So this is to give us the critical t-value. So from the critical t-value, I'm going to project the t-table. So the t-table there is projected. So we have one tail and two tails. So this determines for the one tail, whether you are using a one tail test, two tails, whether you're using a two-tailed test. So at one tail, whatever's been given here, these are the levels of significance. The level of significance. Like here we have T of 0.50, T of 0.75. These will form, this forms the confidence level, but now what is in line with the tail, whether one tail or two tail, is now the level of significance. So we are working with a two-tail test, and our level of significance is 0.05. So here we have the 0.05, and the degrees of freedom is n minus 1. So the sample size was 10. 10 minus 1 is 9. So we have in line with 9 and 0.05 in line with the two-tail. So this gives us a value of 2.262. 2.262. So that is the critical T value, 2.262. So the critical T value is plus or minus 2.262. So here now it's minus 2.262. So that is the critical T value from the table. So here we were using a two-tailed test. And I've told you how. Do you read the value from the T table? So we have the column of, sorry, there's the row of one tail, and then there's the row of two tail. Then below it, we have the column of degrees of freedom. So here we're working with 9. And for the two tail, look for alpha is 0.05. So we are looking for a value that is in line. So that is in line with 9, and it is also in line with the 0.05. So we find that value to be 2.262. And given that it's a two-tailed, so to the right-hand side, we'll have 2.262. To the left-hand side, we are going to have minus 2.262. Then we move to the test statistic. So for test statistic, this step 3, test statistic. So for test statistic, it's the t-test, which will be given by the sample mean minus the population mean over the sample standard deviation divided by n. So what we have, this is the sample mean. This one is the population mean. S is the sample standard deviation, or in this case, just say it's the standard deviation, and n is the sample size. N is the sample size in this case. N is the sample size. So we are going to have it this way. So for the given values, let's find the mean. Because we are done with step 1 and 2, allow me erase this side. So remember, for the values, we have 4,400. So you want to find the mean. So it will be 4400 plus 4800 plus 3700 plus 3900 plus 5500 plus 4000 plus 3700 plus 4100 plus 4000 plus 5400. Then all this is divided by it's divided by 10, which is the number. So let's do this. It's 4400 plus 4800 plus 3700 plus 3900 plus 5500 plus 4000 plus 3700 plus 4100 plus 4000 plus 5400. So we get 43,500. So the mean will be given by 43,500 divided by 10. So this gives us a mean of what? 4350. We now have a mean of 4350. So we have what will be required there. The next thing that we need to get is the sample standard deviation. So if you can recall that, or if I can show you that standard deviation of ungrouped data is given by the sample standard deviation. It will be given by the summation of what is provided, this value is provided, minus the mean squared, divided by n minus 1, divided by n minus 1. So we are going to have a column of the values given, x, and on this column is x minus the mean squared. So we have 4400, there is 4800, we have 3700, 3900, 5500, 4000, 3700, 4100, 4000, and 5400. So we have 10 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in the first case, we have our mean. So for the first one, it will be 4400 minus 4350 squared. I get 2500. Next, 4800 minus 4350 squared. (4800 minus 4350 squared), I get 202,500. Next, 3700 minus 4350 squared, I get 422,500. Next, 3900 minus 4350 squared, I get 202,500. 202,500. Then 5500 minus 4350 squared, I get 322,500. Next, 4000 minus 4350 squared, I get 122,500. Then 3700 minus 4350 squared, 422,500. Next, 4100 minus 4350 squared, 62,500. Next is 4000 minus 4350 squared, 122,500. Next, 5400 minus 4350 squared, 102. It's 102,500. One 102,500. Then you should get the summation of x minus the mean squared. So add all these values. So it will be 2500 plus 202,500 plus 422,500 plus 202,500 plus 1322,500 plus 122,500 plus 422,500 plus 62,500 plus 122,500 plus 102,500. We get 3,985,000. 3,985,000. So once we have this, we already know that to get standard deviation, it will be summation of this. So the standard deviation will be given by the square root of what? Summation of that, we get it as 3,985,000. 3,985,000 divided by 10 minus 1. So 10 minus 1 is what? 9. So allow me have it. Let me just have 10 minus 1, which is 9. So 3,985,000 divided by 9, then you get the square root of the answer. So for the square root, we get that the standard deviation is 665.415. 665.415 hours. This one, you found the sample mean to be 4,350 hours. Recall that all this is to assist us get what? All this is to assist us to get the test statistic. So allow me record this somewhere, that the sample mean is 4,350 hours. The sample standard deviation is 665.415 hours. This is the sample standard deviation. So let me finish my step 3, which was to get the test statistic. So in getting the test statistic, so that is step 3, test statistic. And in this case, we are working with t-test. So this will be the t-test, which will be the sample mean minus the population mean over sample standard deviation divided by the square root of n. So the sample mean, population mean, check the way you stated the null hypothesis. The hypothetical mean we are told is what? 4,000 hours. So this will be 4,350 minus 4,000 divided by the sample standard deviation, which is 665.415 over the square root of what? 10. So our t-test will be what? So this will give us a t-test of solve this. I've started with the square root of 10. So 665.415 divided by the square root of 10. Then 4,350 minus 4,000 divided by the answer. Then I come to step 4, which was so I've determined my test statistic. What did I take? I found the sample standard deviation. After finding the sample standard deviation, so I took the population mean, so 4350 minus 4000 divided by 665.415 over the square root of 10. So this is my t-test. Next, I move to step 3, step number 3. So in step 4 now, step 4, acceptance and rejection region. So I now have, using that critical value, we found it as 2.262, this negative. This also positive 2.262. So this will form rejection region, the shaded parts. This one is acceptance region, and this one is the rejection region. So next I come to step number 5, which will be now what? The decision. Or I can finish with it, acceptance region and the decision. So with the acceptance region, decision, so let's have it. I already have this minus 2.262, and this one is 2.262. Then I have my value 1.663, 1.663. It's less than 2.262. So it will fall in the acceptance region. Only a value that is greater than the critical value, either the T critical or Z critical, will fall in the rejection region. Here we have acceptance. Acceptance region is this shaded and shaded part. So let me have it this way. This one is acceptance region, and this one is rejection region. So you find that the 1.663 falls in the acceptance region, and there we have 0. So accept HO, that is null hypothesis. Why? The value of test statistic, the value of test statistic falls in the acceptance region. The value of test statistic falls in the acceptance region, meaning there is no difference, between the sample mean and population mean, between the sample mean and population mean. Meaning there's no difference between the sample mean and population mean. Hope you've seen the steps that we followed. We followed all the 5 steps of hypothesis testing, and we've come up with a decision. Recall that a decision we can either, for the test statistic, when testing hypothesis, it can either be a Z test or a T test. So let me get another example so that we do. Another one is November 2019 question 2 part B. November 2019 question 2 part B. question 2, part B. So the question says that a manufacturing company is testing a plant for acceptance. For the plant to be accepted, the mean reflectometer reading should be 19.5 and above. A random sample of 25 readings is taken and found to have a mean of 19.7 with a standard deviation of 1.5. So for the plant to be accepted, we have the mean reflectometer should be 19.5 and above. So what will happen here is that we start with the steps of hypothesis testing. So we have step 1. Step 1 is the null and alternative hypothesis. Null and alternative hypothesis. So for the null and alternative hypothesis, we are going to have HO. The mean reflectometer reading should be 19.5 and above. So this one is greater than or equal to what? 19.5. From what you've been given. Otherwise, when will the reflectometer not be accepted? When the mean is not 9.5. So the mean is not 19.5. So you should also know how do we state the null hypothesis. Next, we come to the critical value, step 2. Critical. In this case, look at the sample size. The sample size is less than 30, 25. So this will be the critical t-value at alpha is equal to, so we've been given a C of 0.9595%. Alpha is given by 1 minus C. So 1 minus 0.95, we find 0.05. So at alpha is equal to 0.05, the significance level, degrees of freedom, DF is degrees of freedom, which is equal to n minus 1. In this case, 25 minus 1. We are working with what? 24. And it is a two-tailed test. Two-tailed test because the direction of alternative hypothesis. So this is HA. The direction of alternative hypothesis has not been given. So let's work with that. So we are going to check your table on the part of two-tailed, 0.05 in line with that, then DF here go to 24. So the value that is in line with 24 and also in line with 0.05. So here we have 24. So the value that's in line with 24 at 0.05 two-tailed, we have it as 2.064. 2.064. So we find this to be minus 2.064, yet it's 2.064. That's it, 2.064, 2.064. Step number 3, we calculate the test statistic. Step number 3, we calculate the test statistic. Step 3, test statistic. So in this case, it is the t-test, which is given by the population mean, sample mean minus the population mean over the sample standard deviation over the square root of n. So from the question, we can tell that the population mean is 19 point what? 19.5. The sample mean we've been given to be 19.7. Sample size is 25. The sample standard deviation as we've been given as 1.5. So in this case, the t-test will be, let me preserve space. So the t-test will be 19.7 minus 19.5 over 1.5 over the square root of n, which is the square root of 25. (1.5) divided by the answer, 1.5 divided by 5, then 19.7 minus 19.5 divided by the answer. So we find our t-test to be 0.667. So if it is 0.667, so we come to what? Step 4. So for step 4 is the rejection and acceptance region. So for rejection and acceptance region, so we have minus 2.064, and here we have 2.064. So this one is rejection region. This one is acceptance region. This one is the rejection region. Rejection, acceptance. So we have to. So next we come to the decision. So based on our test statistic, so what are we going to do? I know we are done with the step 1 and 2. Now moving to the last step, which is step 5. And step 5 is all about decision. Step 5, decision. So when we are making the decision, what do we say? So we have 2.064 minus 2.064. So 0, and we found that to be 0.667. So this one is in the acceptance region. This other one is rejection region. So what do? We say what? Accept null hypothesis HO as the value of test statistic false in the acceptance region. So if it falls in the acceptance region, what does this say? It shows that it shows that the plant will not be accepted, meaning the plant will not be accepted, meaning the plant will not be accepted. So the plant would have been accepted only if we would have rejected the null hypothesis, of which we have not done. That's it. So let's try one for Z-test, hypothesis test about one population mean, where we are working with or the only difference between these two, when you are working with Z, it should be to determine the critical value of Z. And I told you how to determine the critical value of Z. So in this case, if it's Z test, it will just be the standard, the population, so the sample mean minus the population mean over the sample standard deviation. So now it's population standard deviation. So it still remains here the standard deviation. So the only difference is that here I'll be given standard deviation. So for t-test, I can be provided with the standard deviation or I calculate it, but here I'll be provided with it. So the two examples that I've done, it shows us how hypothesis test about one population mean. So it's about one population mean. So let's go to next hypothesis test about two population means. And this one, they always like to examine it. Like in the last sitting, hypothesis test was about 14 marks. You can imagine. So let's go to hypothesis test about two population means. So in this case, what happens is this. We are going to have, you need to know how do you determine the test statistic. And here in this case, it will be the Z test. Test statistic for two population mean. So test statistic. So we can either work with, here it can also be a Z or T. So test statistic. So T test will be given by the sample mean of 1 minus the sample mean of 2. So let me ensure the board is back. So it is the sample mean of 1 minus the sample mean of 2 divided by the square root of the sample standard deviation of 1 squared over n1 plus the sample standard deviation of 2 squared over n2. So 1 is first sample, 2 in this case is the second sample, x1 is the sample mean of first sample, sample mean of the first sample, x bar 2 sample mean of second sample, N1 sample size of first sample, N2 sample size of second sample. Then, if it is a z-test, now it becomes easier. Still x1 minus x bar 1 minus x bar 2 over, now the standard deviation of 1 squared over n1 plus the standard deviation of 2 over n2. So 1 still remains first sample. 2 still remains second sample. This one, x bar 1 sample mean of 1 of sample 1, x bar 2 sample mean of 2, oh, here there was something I didn't say about S. S1 is sample standard deviation of 1, sample standard deviation of 1. And here S2 is sample standard deviation of 2, sample standard deviation of 2. So here D1 is population standard deviation of 1. D2 is population standard deviation of 2. So here I'm going to work with 2 examples. So the last sitting, the last immediate sitting, which is September 2021, question 3, part B. 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 The question says that Malimali Supermarket operates 2 branches, one in Kisumu and one in Mombasa. So let Kisumu be 1. In this case, we are talking about branch 1, and Mombasa be 2. In this case, let's talk about branch 2. A sample of 40 employees were taken from Kisumu. So in this case, Kisumu, here let's talk about Mombasa. This one is 1, this one is 2. A sample of 40 employees were taken from Kisumu. So N1 is 40. And a mean wage of 12,000. Their mean wage is 12,000. And a standard deviation of 1,000. A sample of 50 employees was taken from Mombasa, 50. Mean wage is 13,000. Sample standard deviation is 1,200. Advise the management of MMS whether there's a significant difference between the wages paid in Mombasa and Kisumu. The first thing, we've seen the two sample sizes. So with the two sample sizes, what can we say? We can say that the sample size, the two sample sizes are above 30. So we are going to work with a Z-test. So the first step, step 1, we are going to state the null and alternative hypothesis. So we have it as null and alternative hypothesis. So we have HO, that there's no significant difference between the two means. So we'll have it as the mean of 1 is equal to the average of what? 2. That is, the mean wage in Kisumu is equal to the mean wage in Mombasa. But for HA, we say that the two mean wages are not equal. The two mean wages are not equal. So if they are not equal, that's it. So in this case, for two population means, at all times we'll be working with two-tail test. Step 2, we are going to work with the critical Z value because the sample size is above 30 for each at alpha is equal to 0.05. So we have this. We want to determine the critical value. Recall that we said that the So we have this. So remember this 0.05 is to be shared. So alpha over 2, here we also have alpha over 2. So the 0.05 divided by 2 is shared between the two shaded areas. So 0.05 divided by 2. We have 0.025. This other is 0.025. So recall that the area of this half is what? 0.5. So when you pick 0.5 minus that, we get 0.475. So we are working backwards. So when you are working backwards, let me project for you. The Z table. So we come at 0.475. So when we are at 0.4750, we find that what's in line with it, 1.9. And here, see 0.06. So we find that this critical value is what? 1.968 minus 1.96. So after determining the critical value. Next, we come to step 3. So step 3 is the test statistic. So for test statistic, it will be the z-test, which will be x1 minus x2, the mean of 1 minus the mean of 2, over the square root of standard deviation of 1 over n1 plus standard deviation of 2 squared over n2. That's what I had given you. So this comes to be 12,000 minus 13,000 over the square root of what? This one is 1,000 squared, 1,000 squared over 40 plus 1,200 squared over 50. So this gives us a z-test of what? Let's do this. So we find that the z-test is 12,000 minus 13,000 over square root of what? Here it is 25,000 plus 1,200 squared divided by 50, we find 28,800. So 25,000 plus 28,800, you get its square root. So that should be divided by 12,000 minus 13,000. We find negative 4.311. Negative 4.311 is the square root. So it's the test statistic. So once we have our test statistic, what do we do next? We come to step 4, the acceptance and rejection region. So the shaded part is 1.96 minus 1.96. So this one is acceptance, this one is rejection region, this one is also rejection region. Then we come to step 5. Now the decision. So the decision is going to be minus 1.96, it's 1.96. So test statistic, we have it as negative 4.311. Negative 4.311. Recall that this one is rejection, acceptance. So what do we say? Reject. Reject, null, hypothesis, because value of test statistic falls in the rejection region, meaning there's a significant difference between the wages paid in Kisumu branch and Mombasa branch, meaning there is a significant difference between wages paid in Kisumu and Mombasa branches, meaning there's that significant difference. So since I was off, maybe you could not hear me. We are working with November 2018 question 1C. November 2018 question 1C. So for November 2018 question 1C, we have Department P and Department Q. So Department P, N129 to 60,000, 25,000 as the standard deviation. The sample size is 24. Sample mean 310,000. Sample standard deviation is 30,000 for the two departments. So we state the null and alternative hypothesis. Here we have it. Step 2 is now the critical value. Because there's two sample sizes, both of them are less than 30. So it's the T critical value at alpha is equal to 0.05 to 10, but we have to get the degrees of freedom, N1 plus N2 minus 2. So this will be N1 minus 1 plus N2 minus 1, which becomes N1 plus N2 minus 1. We find that. So we go to 210, alpha 0.05, BF51. So a value that is in line with 51 and also in line with 0.05. Okay. In my table, or let me use another table. In my table, you cannot see N51. So let me use another table. So let me use another table. Or let me just share this. We have it stopping at 60, the DF. just a minute. Let me project another one. So this is my table. And here we are working with the two-tailed. Two-tailed. So we have, it's 95% confidence level 0.05. So it's 51. So you can see at 51, we have 2.008. I had to look for it because in our table, it was not there. Remember, if you have to work with that in a table that you are given, there should be 51 degrees of freedom. So we have the critical value, which is now 2.008. So we find that to be 2.008. Let me have it shared there. You can see it's 2.008. So this minus 2.008, this one is 2.008. So let's go to step 3. I know you have this. Step 2, we are done with it. I want to erase this part. So capture it now. So let's go to step number 3. Step 3. Test statistic. So the test statistic will be given by, here it is t-test over the square root of S1 squared over N1 plus S2 squared over N2. So this will be its t-test. So this is 260,000 minus 310,000 over the square root of 25,000 squared over 29 plus 30,000 squared over 24. So the t-test will be given by 20. To 60,000 minus 310,000. So this becomes 21. 55, 1, 724.14 minus 30,000 squared divided by 24. 37,500,000. So 21 . So this one, even when we do it, we are going to get a negative. And when you get a negative, that's where you are going to stop. So it showed that that question had an error, a little error. It had a little error, but what I wanted to show you is how you determine the t-test. So I'll stop at that. So next, because you cannot have square root of a negative value. So next we move to hypothesis test about a population proportion. Hypothesis test about a population proportion. So when I'm talking about proportion, like if out of hypothesis test about one population proportion. Like let's say you interviewed 1,000 people, 100 people. So out of these 100, 20 preferred, 20 preferred maybe a given form of news. We can talk TV. So the proportion that preferred TV will be 20 over 100 times what? 100%. So we find that that proportion is what? We find that the proportion is 20%. So that's what you should need to understand about proportion. So let's have this question. In a random sample of 100 units from assembly line, 22 were defective. In a random sample, so it says in a random sample, in a random sample of 100 units from assembly line, 22 were defective. Does this provide enough evidence at 0.05 significance level? That the defective rate among all units exceed 10%. That the defective rate among all units exceed 10%. So when we are talking about this, here it's about population proportion. You need to know this. So P, population proportion. This one is sample proportion. Sample proportion. So we have step one. Step one, null and alternative hypothesis. HO, the proportion is 10%. So in this case, let's say H of P is equal to 0.1. H P exceed 0.1. Step 2, critical Z value at alpha is equal to 0.05, 1/10. So we have this area is 0.05. So it will be this area if the total is 0.5. So 0.5 minus 0.05, this is 0.45. So let me project 0.45. So we need 0.450. So it's in between 4495 and 4505. Therefore, it is 1.645. 1.645. It's between 4495 and 4505. So that's make it to be 1.645. 1.645. So we now come to step number 3. Because you have the question, let me eliminate this. Step 3, test statistic. In this case, Z test. For population proportion, it's going to be what? So for population proportion, it's going to be the sample proportion minus population proportion over PQ over N. So we have the sample proportion. We were told that 22 were defective out of 100. So this will be 22 out of 100. What do you get? 22 out of 100. We have 0.22. Then P we've been given there as 0.1. Q is equal to 1 minus P, which is 1 minus 0.1. So 1 minus 0.1, we get 0.9. And we have it as 100. So this Z test will be the Z test. Z test will be 0.22 minus 0.1 over the square root of 0.1 times 0.9 over 100. So this will be we find the Z test to be what? 4. We now come to step 4, decision. So there's no need, I can just skip step 4, combine step 4 and 5. This was 1 point, sorry. It was only 1, so 1.645. So this will be acceptance, rejection. So 4 will be in the rejection. Decision, you do what? Reject, null, hypothesis. Why? Value of test statistic. Write whatever I'm saying. Reject, null, hypothesis as the value of what? Value of test statistic falls in the rejection region. Reject, null, hypothesis as value of test statistic falls in the rejection region. Reject, null, hypothesis as the value of test statistic falls in the rejection region. Reject null hypothesis as the value of test statistic falls in the rejection region. So that's it. The last part is hypothesis test about two population proportion. Hypothesis test about two population proportion. Hypothesis test so we already know about sample proportion and population proportion. So one represent population proportion 1, which is P1. 2, population proportion 2, P2. So how will we get the test statistic? So this one is sample proportion 1. This one is sample proportion. P is overall sample proportion. So the z-test will be P1 minus P2. So the sample proportion 1 minus the sample proportion 2. The body will be back in a moment. So P1 minus P2 over the square root of overall sample proportion into 1 over N1 plus 1 over N2. So we already know as N1 sample size 1, N2 sample size 2. So when you want to get P, this one will be X1 plus X2 over N1 plus N2. That is the sample size of 1 plus the sample size of 2 divided by. So whatever value that you have in 1 over whatever value that you have in 2 divided by the 2 sample sizes. So how will we be able to see that? Let's go to May 2019 question 3 part B. May 2019 question 3 part B. May 2019. If I'm passed first, you'll pause the video so that you can capture whatever is discussed earlier. So it's May 2019 question 3B. It says, better limited deals in the manufacture of detergent known as Safi. A recent survey undertaken to determine the percentage of residents who use Safi required that 500 residents, only 10% use Safi. So 1, we have N1 is equal to 500 and P1 is equal to 0.10. So X1, we don't know. So this should be P1 is equal to X1 over N1 times 100. So let it be X1 over N1. So 0.1 should be equal to X1 over 500. So X1 is equal to 500 times 0.1. So X1 is what? We find that X1 is equal to 50. So we found it to be what? 50. Then after a campaign, so this one is before campaign. After campaign, this one is 2. We have 600 residents, so N2 is 600. P2 is equal to 0.15. So what is X2? 0.15 X2 over 600. So X2 is equal to 600 times 0.15. We find 600 times 0.15. We find 90. So this one is 90. So let's find P. X1 plus X2 over N1 plus N2. So this P should be 50 plus 90 over 500 plus 600. We find it to be what? We get what? 0.1273. We get 0.1273. So all these, let me note them here. N1, we found it to be 500. X2, we found it to be 50. We found it to be 50. We have N1, 500, X1, 50, P1 is 0.1, N2, 600, X2, 90, P2, 0.15, and the overall P, 0.1273, 0.1273. So let's start with step 1. So whatever calculation I've done is necessary such that I'll now just be calculating null and alternative hypothesis. So I'll say that there's no difference between the two population proportion. P1 is equal to P2. Alternative hypothesis, there is difference. P1 might be greater, P2 less, or P2 greater, P1 less. Then step 3, it's the step 2 is the critical Z value at alpha is equal to 0.05. I know by now you know that this one will be. It is two-tailed. Two-tailed. So this one will be minus 1.96. This one is 1.96. Step 3. I come to do what? Step 3 is now the test. Statistic. So I already know that Z test is given by sample proportion 1 minus the sample proportion 2 over the square root of the population proportion, overall population proportion into 1 minus the overall population proportion into 1 over N1 plus 1 over N2. So our Z test will be 0.1 minus 0.15 divided by the square root of 0.1273 into 1 minus 0.1273 into 1 over 500 plus 1 over 600. So let us calculate this. We find this to be the Z test to be negative 122. Oops, we were to get the square root of that. Let me redo this. No, that's not the case. Let me redo it. I get negative 0.05. So after I've gotten negative 0.05, what do I do? The next thing that I'm going to do is this. I now come to step 4. Decision. So 1.96 minus 1.96. So it is at negative 0.05. So here we have what? Acceptance. Here is rejection. So do not reject null hypothesis. Why? Value of test statistic falls in acceptance region. The value of test statistic falls in what? Acceptance region. meaning the advertising campaign did not increase the usage of what? Safi. Advertising campaign did not increase usage. Advertising campaign did not increase usage. Advertising campaign did not increase usage. So that's all on hypothesis. Go through whatever you've done, look at it keenly. So that's the end of our class today. Next, we'll share recording on linear programming.